All right, we have a 747 plane starting from rest, and it needs to get up to 80 meters per second in order to take off. We've been given an acceleration. We want to calculate the distance it needs to be able to reach the speed and the time it takes. So let's be clear. It starts from rest. That tells us u equals 0. And v ends up being 80 meters per second. We have an acceleration. So let's go ahead and fill out the SUVOT variables and then use SUVOT to solve the question. So we don't know how far it's going to go. We know that it starts at a speed of 0 meters per second. It's going to get up to 80 meters per second. We know the acceleration is 2 meters per second squared, and we don't know the time that it takes to do that. So let's calculate the distance it takes to be able to reach the speed. And sorry, this should be a question mark. So continuing here, we actually do not know the amount of time it's going to take. So let's go ahead and use our third equation. So v squared is u squared plus 2 times a times s, and we'll plug in our variables. So 80 squared equals 0 squared plus 2 times 2 times s. We're going to end up getting 6,400 equals 4 times s. We'll divide both sides by 4, and so the distance it needs to reach this speed is 1,600 meters. Awesome. Now we can go ahead and get the time. I'll use the formula v equals at plus u. So we're going to end up having 80 meters per second equals 2 times t plus 0. We end up getting that 80 is 2 times t, and dividing both sides by 2, we're going to end up getting the time is 40 seconds. Awesome. Let me just go ahead and circle these answers so we know that those are the right answers. Whoops. Yeah. So that's part A. Now let's go ahead and do part B. So a car is initially moving at 20 meters per second. It needs to stop before hitting a wall 50 meters away. We want to know the value of the braking acceleration, and we want to know how much time it will take to get to that wall. So let's go ahead and do that. So S is 50 meters. U is 20 meters per second because that's what it starts at. It ends up at a speed of 0 meters per second. We don't know the acceleration, and we don't know the time. All right. So let's go ahead and see if we can use the third equation, since we don't have time, in order to solve for the acceleration. So v squared equals u squared plus 2as. So we're going to have 0 squared equals 20 squared plus 2 times unknown a times the 50 meters over which it travels to stop. So we get 0 equals 400 plus 100 times a. I can do that because of both the commutative and the associative property. So continuing with this, negative 400 taken from both sides equals 100a. We'll divide both sides by 100. And so that's going to give us an acceleration of negative 4 meters per second squared. Awesome. Now we can go ahead and use that to get the time. So there's the acceleration. Now we get the time. V equals at plus u. So that's going to be 0 equals negative 4 times t plus 20. Let's subtract 20 from both sides. That's going to give us negative 20 equals negative 4 times t. We'll divide both sides by negative 4. This cancels. And so we're actually left with 5 seconds as the time that we solved for. All right, there we go. So that is question number 4, and we'll take a look at question number 5 in the next video.